Hey buddy, so we've got this interesting problem in our IT journey, haven't we? It's about locating a subarray within a given array whose sum equals 0. Imagine we are given this array. Now, this doesn't make sense at first glance, right? Except it gets intriguing when you try to find some numbers in a sequence that add up to 0. Doesn't that feel like solving a puzzle sometimes? Okay, let's dive into Python to tackle this. We'll just set up a simple list with integers and begin the conversation with our approach. We start by creating an empty cache and a dictionary to store our results. It's like we're gathering memories to recall later, you know. I'm imagining using a brute force method at first, looping through every possible subarray and checking the sums. This way, it would just consider all combinations, but we both know that's a noisy party. It's just not efficient enough, especially as the list grows, and it sounds like pure chaos. And we both hate chaos, don't we? To refine our strategy, we should introduce some Python tools. A dictionary and conditional checks sound like the perfect duo. And just like in life, we need to optimize, otherwise, we'll be running around in circles unnecessarily. We'll work backward, calculating the sum while iterating through the list, and when we hit a balance, say, the sum's 0, we know we've found our subarray. It's like finding a treasure chest when we reach the shore. The anticipation is just right. Imagine now an elegant flow. As we step through the array, the running sum helps us. Let's say our starting point is the first element. We move forward, add up as we go. As soon as this running sum hits 0, congratulations, we've found a piece of the treasure chest. Our code will remember this balance point, storing it with the starting index of when this sum was ever hit before. Now, isn't that like holding a memory of where we started to find our piece? But wait, our Python journey takes a twist. The algorithm might loop in circles, you see. We fix this by tweaking our code. When we find a balance, instead of celebrating just yet, we store the starting point and the running sum into our dictionary. It's like setting a rendezvous with a friend to reconnect later. This way, if we encounter our sum somewhere else down the line, bam, we've got a shortcut back to that moment of balance. The brute force party is now a casual meetup after discovering shortcuts. These shortcuts are what our dictionary's for. We've turned into detectives using these past encounters to find clues. And if the sum doesn't hit 0, the negative case isn't lost in this tale. We flip our sign, seeking it as a treacherous mountain trail looking forward, yet still within our algorithm's heart. As our algorithm runs, it's performing its detective work. The dictionary holds the keys to revisiting our subarrays and their sums like old memories, which we then cherish. We are using less than half the resources it might have taken to go through the list twice for the same purpose. So efficiency feels like finding a secret garden hidden in the middle of a bustling city, and our Python code is the map leading us there. But we're in this together and always aim to learn and improve. So let's also ponder a couple of other techniques that we could compare with our current method. Dynamic programming could be an option, or even divide and conquer, breaking down the list into smaller parts to make calculations manageable, like sharing tasks among friends. We can explore these and find one that brings out the best of our programming flair. Now, imagine the code doing its thing, iterating and storing in that dictionary, acting as a guardian of balance for subarrays like a treasured secret. As it moves forward, the complexity of its role becomes evident. We are dancing with time complexity, swaying towards better performance with every move. The steps are calculated and refined as we iterate, finding the balance, the zero sum, the elusive treasure amongst a sea of numbers. And there, among the numbers, a Subarray with a sum of 0 reveals itself, like a secret handshake between strangers meeting on the same street after years. It's not always about the longest or straightest path, but sometimes finding the moment of connection that sparks joy. And as we find this Subarray, this moment of connection, we've unlocked the puzzle with our Python dance. We've crafted this solution like an artist, and every line of code adds to the masterpiece. Efficiency, memory, and speed are our vibrant colors. I'm convinced that this discussion will inspire us to keep seeking more elegant and optimized solutions, always refining our coding art. Feel free to jump into Python or any language of your choice on your side, and remember, the sky's the limit. Keep refining, keep coding, and above all, keep it fun. Visit neeraj.qzz.io and subscribe to TechLab for new insights and discussions. Let's continue this fascinating dialogue in the community.